Welcome back to the machine learning part of the logistic regression. Let's continue from the point where we stopped in the previous lecture. So far, we got our data ready for machine learning algorithm. We fixed the missing data issues, created dummies for categorical variables, and dealt with multicollinearity issue. Then we dropped the column we didn't need. Let's move on and separate our data into X and Y, where X is going to be the features and Y is going to be the target values. So X equal to train dot drop survived. X is equal to 1. So what we need in X, we need all the features. This is why we are going to drop a single column survived. So we are getting all columns other than survived in X. And our Y equal to train, and we need to grab the column that we are dropping in X. Let's run this cell and add few cells to make space. And good idea to check the head of our data frame X. Here we have P class age. We don't have survived column in our features, which is capital X. The next step is we need to import train test split because we are going to split this data into train and test. So from Scikit-learn dot model selection import train test split. Let's run this cell and train test split. And if we press Shift Tab, we can copy the code from the documentation string just to save some typing. This one here, Control C, paste it here, delete these dots, split this into two lines. These are two extra dots as well. And I'm going to leave test size 0.33 and random state, which is default value 42. Let's run this cell. Now we got X train, X test, Y train, and Y test. We need to import the logistic regression model as well. Logistic regression is a part of linear model family. So from Scikit-learn dot linear model import logistic regression and run this cell, and now create an instance for logistic regression. So we can call log R equal to logistic regression and run this cell. We have log R as an instance for logistic regression. The next step is to fit the data on our training data set. This is training our model. So log R dot fit and pass in X train and Y train. And let's run this cell here. So our model is trained on the given data set. Default parameters are shown here. Let's get the predictions for our data set from the training model log R now. So pred equal to log R dot predict, and we pass in X test here, and let's run this cell. So there's no error, it's working properly. Let's add few cells and move on to the evaluation process. Evaluation process has its own importance. We want our model to be as good as possible in predictions. Scikit-learn provides a very nice and efficient way to evaluate classification tasks using its classification underscore report module. We need to import classification underscore report to use this module. Let's go ahead and do another import from scikit-learn.matrices. Import classification report and run this cell. Let's pass in the observed values, which are y-test and predictions, to the classification report and see the performance of our model. So print classification report. If you press Shift Tab, Y true and Y pred. So our Y true is Y test and our Y pred is pred, which is this one here. And let's run this cell here. And here we have a report on our model. The classification report outputs the precision, recall, F1 score, and support cases for each class along with their averages. It's all up to us. If you don't want the classification report and interested in confusion matrix to calculate the specific value, we can get that one as well. Let's get pure confusion matrix now. To get the confusion matrix, we need to import another module, confusion_matrix, from Scikit-learn.matrices. Import confusion matrix and run this cell, and then confusion matrix, and once again press Shift Tab, Y true and Y pred. So we need to pass in Y test and our predictions and run this cell here. So here we have a confusion matrix. So the numbers are suggesting that our model is performing quite good. It's not that bad. So let's have a quick overview on the machine learning section. So after getting the cleaned data, we passed in features to capital X and the target values to Y. Then we moved on and used train test split and splitted the data into training and test dataset. After splitting, we imported Logistic Regression model and created its instance. Using that instance, we trained our model on the trained dataset and then used the trained model to get the predictions for our test dataset. We imported classification report and passed in the test, which are observed value, and predictions, which are the predicted values from our model, and got the numbers in classification report, precision, recall, F1 score, and support cases. We also got the confusion matrix at the end to see how our model is performing. So guys, this was really extensive learning in this logistic regression section. In this project, we have done lots of steps that we do as a data scientist on real-life datasets. Most of the times, we clean the data and transform the data into an acceptable form for the machine learning algorithm. You have noticed that the machine learning libraries are quite simple and they are very straightforward to use. We spend significant amount of time in data cleaning and preparation. The machine learning is somehow easier part at the end. So understanding the data is the most important thing before you move on to the machine learning section. Once again, considering the amount of data that we used in this section, the results are not very bad. However, they are not very good as well. Please note, we only used a part of Titanic data, which is train part. If you use train and test both parts, the results can be improved using the same model. You can find both CSV files on test and train dataset in the course material. A Titanic_full.csv file is also included in the course material. I suggest go ahead and use a full dataset to train your model and see how the results are different. Few things that you may want to consider while practicing. Notice that the P-class column is actually a categorical column. You only have 3 classes. You can get dummies for P-class column as well. Try getting dummies for P-class column and rerun the machine learning section to see the difference in your results. In this lecture, we only got dummies for sex and embarked column. So getting dummies for p-class column would be another good practice exercise. You will also learn how the machine learning algorithm treat a column as a category versus a continuous variable. Another thing I want to mention here, look at the ticket column. You may get some information from the ticket column. The title or prefix of a name like Mr., Mrs., or Doctor could be another feature to use. Titanic dataset is very popular for classification problem, and there are a number of good kernels on Kaggle. Check the Python ones. You may get an idea to improve your model. The kernels in other languages, such as R, are also useful. You can get an idea on data cleaning, plotting, and some feature engineering that you can implement in Python as well. You did a wonderful job so far. Once again, this logistic regression was really an extensive lecture. We did lots of steps and it was kind of a real life project. I suggest revise this lecture, do the practice before you move on to the next lecture where we are going to do some practice exercises. See you in the next lecture. Good luck.